This morning, my father asked me to pick up for him a chocolate cream pie. And he said that if I picked one up for him, he would let me have some of it. He said that if I got it for him, I could either get 1/3 of the pie or 3/6 of the pie. I get to choose. So I'm sitting here trying to figure out which one I want. And it's kind of hard to think about because I don't know which one's more. If they both have the same denominator, it would be easy to find out, right? If he said I could have 1/3 or 2/3, obviously 2/3 is more, and I would get that one. But that's not what he said. He said 1/3 or 3/6. And I don't know which one is more. I wish there was some way that I could figure that out so that I could find out which one I want to have. What I really need to do is figure out how to compare fractions that have different denominators.
Before we find a solution to my problem, we're first going to play a game called Which Fraction is What Size? Here is our first problem for you to solve, contestants, and it is the question, what fraction is less than 1/3? Can anyone find that? Well, looking at our fraction wall, we can see that 1/4 and 1/5 are less than 1/3. Congratulations if you got that right. Let's move on to our next question. The next question is, which fraction is greater than 2/3? So you're going to have to try and figure out which fraction is more than that yellow part shaded in. And the answer is 1 whole and 2 halves and 4/4 and 5/5 are all greater than 2/3. And in fact, 3/3 is also greater than 2/3, but I couldn't figure out a way to shade in both of those things at the same time. Next question. Next question, can you find a fraction that is between 1/2 and 2/3? Let's see if you can find it. And the answer is 3/5. It's slightly larger than 1/2 and slightly smaller than 2/3. Next question. Can you find a fraction that is in between 1/2 and 1/4? Correct. There are two options for that one. There is 1/3 and there's also 2/5. Both of them are slightly smaller than 1/2 and slightly larger than 1/4. Oh, here's a different kind of question. See if you can answer this one. Which one is greater, 2/3 or 3/4? Oh, that's a tricky question because they don't have the same denominator, so they're not easy to compare. But luckily we have a fraction chart, so we can just shade them both in on the fraction chart. And after we shade them in on the fraction chart, we can clearly see that 2/3 is less than 3/4. Next question. Which one's greater, 2/3 or 3/5? Well, that's a hard question to answer because we don't have the same denominator on them, so we can't compare them directly, but luckily we have a fraction chart. Let's color them both in. There we go. 2/3 at the top, 3/5 at the bottom, and we can tell that 2/3 is definitely more than 3/5. Next question. Which one's greater, 1/3 or 2/5? Again, they have different denominators. How are we going to figure it out? Well, we'll color it in on the fraction chart. 1/3 at the top, 2/5 at the bottom, and we can see clearly that 2/5 is greater than 1/3. And here's our final question. Which one is more, 1/2 or 2/5? Well, they still have different denominators, so it's not easy to compare them directly, but we can color them in. Colored in 1/2 at the top, colored in 2/5 at the bottom, and we can see that 1/2 is greater than 2/5. Congratulations, contestants, if you got those questions right. Your prize is still nothing. I can't believe you thought you were going to get a prize. This is not a real game show. Okay, so what's the point I'm trying to make on all this? The point I'm trying to make is that when you have the same denominator, it's easy to compare two fractions, right? 2/7 is clearly less than 3/7, just like 2 apples is less than 3 apples, and 2 frogs is less than 3 frogs, and 2 skyscrapers is less than 3 skyscrapers. But when you have different denominators, it's not so easy to compare. You're not comparing apples with apples anymore, or skyscrapers with skyscrapers. You're comparing two different things. If we're comparing 1/3 and 5/12, Wouldn't it be nice if we could somehow change it so that they both had the same denominator? That way we could compare them easily. This is something that mathematicians do all the time. If they're having trouble solving one specific problem, they can try and turn it into a different problem. Let's see if we can change these fractions so that they both have the same denominator. Here I have 1/3 on the left and 5/12 on the right. Let's start by drawing those on the pie, and then we can figure out how to convert one into another, starting with 1/3. So the denominator is 3, so we need to cut the pie into 3 pieces, equal pieces. And then the numerator is 1, which means we only have one slice left, so the other ones are going to disappear, or they're going to become ghost slices anyways. Good, so that's 1/3. Now let's illustrate 5/12. Well, the denominator is 12, which means we have to cut the pie into 12 equal pieces. And there are 5 of them left, so the rest of them will disappear, or at least turn to ghost slices. Now, if we look at the picture, it's clearly obvious that 5/12 is more than 1/3. But sometimes we don't have time to draw a picture. Sometimes we just want to figure it out using mathematical operations. How can we do that? I wonder, is there a way that we can turn the thirds of pi into twelfths of pi? We learned before about how we can find an equivalent fraction for a fraction, right? Is there a way to make 1/3 into an equivalent fraction that has a denominator of 12? How can we turn 3 into 12? Well, we can multiply by 4. And if we multiply the denominator by 4, we have to multiply the numerator by 4 too. Remember when we talked about multiplying, it's the same as cutting when we were looking at our fraction models. So what do we have to do? We need to cut each of those thirds into 4 pieces. That's how we can multiply it by 4. Let's give it a go. First, let's cut the slice that we have into 4 pieces. 1, 2, 3, 4. So now instead of having the numerator of 1, we now have a numerator of 4. Check it out. But remember, we didn't cut the rest of the pie yet, and you can see the slices are not equal anymore. So we have to cut the rest of the pie as well. Each of those other slices needs to be cut into 4 equal pieces. So, 1, 2, 3, 4. 1, 2, 3, 4. Do we now have 12 pieces altogether? Yes, we do. So we need to change the denominator to 12. So 1/3 is the same as 4/12. And now we can compare the numerators easily because the denominators are the same. And we can see 5/12 is more than 4/12. So now we know that 5/12 is more than 4/12, which means that 5/12 is also more than 1/3. Excellent! We just converted to an equivalent fraction so that we could compare fractions that have different denominators. Wow! That's pretty cool. Let's try another one. Which one's greater, 3/4 or 5/8? Well, you know what we have to do first. Let's draw the model. On the left, we have 3/4, so let's divide that pie into 4ths, because the denominator is 4. And then how many do we have? We have 3 of them, so one pie slice is going to disappear. What about the pie on the right? 5/8, so we need to divide the pie into 8 equal pieces. And how many do we have? 5, so the rest of them are going to disappear. Fantastic. Now looking at the picture model, we can see that 3/4 is clearly more than 5/8. But how can we prove that mathematically? Well, we look at the denominator. Is there a way to change the denominator from 4 to 8? What can you multiply 4 by to turn it into 8? 2. And of course, if we multiply the denominator by 2, we have to multiply the numerator by 2 as well. So we need to take each of those 4 slices and cut them into 2 equal slices. Let's do it. Let's start with the slices we have. Cut that one into 2, cut that one into 2, cut that one into 2. And now our numerator is no longer 3. It's 1, 2, 3, 4, 5, 6. But we don't have all equal slices now. We need to keep cutting the pie. There. Now what's our denominator? Our denominator is 2, 4, 6, 8. which is what we wanted all along. Now the fractions have the same denominator, and we can compare them. 6/8 versus 5/8. Well, 6/8 is clearly more than 5/8, so we can say 6/8 is greater, which means that 3/4 is greater than 5/8. Wow, who knew that converting fractions could be so fun? Well, we're going to see how much fun you have, because I'm going to give you some questions to try on your own. You're going to have to convert one of the fractions, probably the one with the smaller denominator, to have the same denominator as the other fraction so that you can compare the two. So use multiplication to multiply one of the fractions so it has the same denominator, and then you can compare and figure out which one is greater. Press pause to give it a try, and then press play to check your answers. Let's check your answers, starting in the top left-hand corner. 1/2 versus 4/10. Well, I guess the question is, how can you turn 2 into 10? You'd multiply it by 5. And since we multiply the denominator by 5, we have to multiply the numerator by 5. 1 times 5 is 5. So 1/2 is the same as 5/10. And 5/10 is more than 4/10, so 1/2 is more than 4/10 as well. Question on the top left, 2/3 versus 5/6. Well, how do we turn 3 into 6? We multiply it by 2. And since we multiply the denominator by 2, we have to multiply the numerator by 2. 2 times 2 is 4, so 2/3 is the same as 4/6. Is 4/6 more or less than 5/6? 4/6 is less, which means that 5/6 is more, so 5/6 is greater than 2/3. Question in the bottom left. 3/5 versus 5/10, which is greater? Well, how do we turn 5, the denominator, into 10? We have to multiply it by 2, which means we have to multiply the numerator by 2 as well. 3 times 2 is 6. So 3/5 is the same as 6/10. Well, 6/10 is more than 5/10, so 3/5 is more than 5/10 as well. Final question, 1/2 versus 7/12. How do we turn 2, the denominator, into 12, the denominator? Multiply 2 by 6. 2 times 6 is 12, which means we have to multiply the numerator by 6 as well. 1 times 6 is 6. So 1/2 is the same as 6/12. But 6/12 is less than 7/12, which means that 7/12 is more than 1/2. And that's how you can convert fractions so that they have the same denominator, and you can figure out which one is more and which one is less.
Here's our pie, and before I figure out how much I want to eat, let's do the multiplication. So my two options were 1/3 or 3/6. So what I'm going to try and do is convert the thirds into sixths. How can you multiply 3 to turn it into 6? Oh, you can multiply it by 2. So I can multiply the denominator by 2. 3 times 2 is 6. And then I can multiply the numerator by 2. 1 times 2 is 2. So 1/3 is the same as 2/6. But the other option I could have was 3/6. So I think 3/6 is more than 2/6. So I'm going to choose 3/6 rather than 1/3. And let's just double check this. I'm going to cut the pie, and I'm going to make sure that my multiplication is correct. So here we have the pie. First I'm going to cut it into thirds. So one of my options is to have 1/3. And so here's 1/3 over here. And then my other option was to have 3/6. So let's turn all those thirds into sixths. How do we do that? By cutting them in half. How do I know that? Because we said multiply by 2. So I'm going to cut each of the thirds into 2. There we go. So my other option was to have 3/6. 1, 2, 3. Oh, that is more than 1/3. Okay, I think I'm going to go with having 3/6 of the pie. Now that I've figured out how much pie I'm going to eat, you need to figure out what to do. I want you to skip a few pages in your Jump Math book all the way to page 218. The other pages are grade 7 stuff, and maybe we'll get to that later, but I want to focus on grade 5 stuff first. So, complete page 218 in your Jump Math book, and then a quiz will pop up in the afternoon. Enjoy your math? I'm going to enjoy, well, 1/6 of my dad's pie. I'll eat the other 2/6 later.